We're moving on to a new segment in the chapter now, and we're going to continue to look at bonding, and specifically we're going to be looking at covalent bonds. So if I can bring you back to our initial flowchart, we just spent a lot of time naming both types of compounds, but for the rest of the chapter we're going to come down here. So we're going to take compounds and we're going to focus on molecular compounds, which are held together with covalent bonds. And we're going to look at Lewis structures and shape and polarity. So that's what we are looking at now. It's all molecular compounds, so electrons being shared, and we're looking at shape and polarity. And at a particle level, this would be like our friend, the water molecule. So it's held together with covalent bonds. Remember, with covalent bonds, these are always between nonmetals. And we're always sharing electrons, right? So when we talk about water, what we will be learning to do with water is not just build it, which you'll get a chance to do either hands-on or digitally, but draw what we call a Lewis structure. So for water, a Lewis structure would look like this. And this starts to communicate something about the bonds and also the electron pairs in the molecule. Then we'll take that structure and we'll make it match up more with what our model is helping us see here, that there's a different shape to that water molecule. So we would find out in nature, off of my paper, that water actually has this bent shape to it. So once we understand covalent bonds, we can draw these structures, then we can put them into the right shape. And then we can also talk about their polarity. And so we will be adding arrows on here as we progress through the chapter to show where electrons are getting pulled. So I'm pulling electrons in the direction of the arrows. And then we'll also show electrons being pulled overall in the molecule. So here's my particles and here's my symbols. And this pink arrow is showing that electrons would be hanging out more often up here by the oxygen, which is represented by the red. Now, who cares? Maybe you've seen, we are in the middle of a pandemic right now, so maybe you've seen some really cool pictures of the COVID-19 coronavirus virus structure. That structure is all coming from these shapes here that we are going to learn about in this chapter. Over here is another thing maybe you've seen with shapes. Maybe in a bio type class or physio, you've seen enzymes that look like this. We have kind of these simple shapes. But in chem, if we take the particles and we actually look at the shape, they're more complex. And these start to look a little bit more like the complex coronavirus pictures we've seen. And so if we can understand shape and polarity, we can start to understand function and properties of different substances. Some cool things that we can do with shape. We can study diseases like our coronavirus. And we can also engineer drugs. Engineering HIV drugs was actually one of the first times that they were able to engineer something that would have the right shape to fit into the active site there. So that's something we can do with our shape. And then also with shape, another thing that we can learn about is mutations of shape. And we might find that to be a good thing or a bad thing. It just depends. So if you have a genetic mutation, it might change the shape of this. That sometimes can happen with the coronavirus as well. Or maybe you want to actually force a shape to be wrong so that you kill a virus or something like that. So this is where we're headed in this chapter, is understanding better where these shapes come from. And there will be 6 different shapes that we look at. So they'll feel a bit overwhelming, but there's only 6, okay? So you'll get the hang of these as we work on them.